Hello, everybody. I'm excited to be here at IBM Developer Day. My name is Viktor Gamov, and I will talk today a little bit about zero trust and the microservices. Before we will jump into all these like technical details, I want to talk a little bit about the actual topic about trust. Sometimes when I talk about this topic, sometimes when I talk about this like zero trust concept, people was a little bit confused. They say like, what do you mean zero trust? Trust is good, right? So trust is good. You're trusting to someone, and it's a good thing to have it in your life. Like without trust, like how you can live happily in this life, right? So the trust can be trust you can develop over the times. Trust can be earned, or you can have a trust given because you working with someone, or like even with your relatives. Like here's the picture from very famous cartoon. Hopefully you know this. This is the Lion King, and this is Mufasa and his brother Scar. They brothers. They have trust, and this is the Scar with young Simba. The Simba trusts his uncle because like why not? But here's the problem with this trust, and this is something that we're going to talk about this today a lot, is that trust is exploitable. So when you trust someone, when you think they will betray you, will they? And as we know in the Lion King, trust was exploited by Scar by betraying the Simba, Mufasa, and he exploited trust that they gave to him. So in this presentation, we're going to be talking about how to remove trust from our more deterministic world of IT, world of development, world of communication and connectivity. How we can, by removing the trust, we will ensure better connectivity and better security for our application. My name is Viktor Gamov. I work as a developer advocate at Kong, cloud connectivity company. At Kong, we do a lot of work around providing tools that you can use on building your applications, building your microservices, and successfully move them to production. We're taking care of some of the day two responsibilities. And one of the things that we build at Kong, I will talk a little bit today. We do a lot of like open source work. Kong Gateway is one of the most popular, one of the pretty substantially followed and start project in GitHub. And today we're going to talk about another open source project that we started around 2019, and we donated this into CNCF. We're talking about service mesh named Kuma, and we will go over these details a little bit. So let me elaborate a little bit on trust and security, and let's talk about let's take another example. Like since you already were set with the concept of zero trust, here's another example. So you travel places, you go places. Thankfully, in 2021, we start getting back to traveling places, seeing people. And when you go into another country, you're meeting these customs and border patrol officer. And I believe many of us who watch this presentation and who are attending this conference never even had in mind to lie or provide some false information in the customs border patrol officer. But how they will trust you if they see you for the first time? The example that I brought you on the very beginning is kind of like, you have this trust because it was not earned, it was given because it was the part of your organization or your family or whatnot. But here, he sees you first time. How he will make sure that you say you are, and there's no criminal intent here. We need to provide a form of identity, so we can provide this form of identity so we can remove trust from this. It's going to be deterministic. It's going to be something that it is true. So how we can solve this? Multipath. Little Dallas multipass. So essentially, you're providing a passport, you're providing a document that already some authority certified and gave it to you, so it will sign your, or like it proves your identity. So zero trust security, one of the pillars of the zero trust security is providing some sort of virtual multipass, or multipass. If you remember this movie like Fifth Element, this multipass or passport or any type of document that certifies your identity. So let's bring the idea closer to the point where we are. So meaning that let's talk about the concept of building applications. Um, Before microservices took over the world, and everyone is telling you that you need to start building microservices, everything was clear and nice, and everything was just in one place. You don't have to worry about this. Marketplace application, just example, like it's the simplest simple possible, the example that we can have in a simple but still complex. We have a multiple modules that they need to be invoked. It may be different packages, different functions, different framework components that your application has. And in order to communicate those services, you just invoke those services. And if you have access to invoke the services on the level of language, if you're using object-oriented language, maybe you're already familiar with concept of encapsulation, and if you allowed to call certain methods, you will be able to you get the access. If you're not, you would not. And different languages and different runtimes provide different ways how you can secure access to certain places. And like I came from the Java world, and Java virtual machine actually has a very sophisticated mechanism on controlling access to the certain things. Even with the new releases of Java 8 and Java 11, the modular mechanism was improved. And it's all nice, and it's all good when you're running this in the world of your monolith. But we know over the years that monoliths are the concept that's not super easy to reason about, or like have everything in your mind. So that's why people start decoupling those services. When you decouple the services, you're not talking about the local calls. You're not talking about calling the code that near to you, or maybe in a closer the register of the processor, or closer cell in your memory. It's somewhere else. So now we need to talk about network requests. And when we're talking about we're lifting this level of abstraction, there's a lot of things can happen. And different components now can run in the network environment. In the network environment, you don't know where you're running. In some cases, in the past, you might even do your own network. Like you have a people that you also certify to do network in your organization. They bring in cables, and everything is secure and whatnot. But how you will be dealing with situation when it's say you deploy application in the public cloud, or you deploy this application in the private cloud, where other participants or other constituents can access to this service. You need to provide a form of identity. You need to include this information with your request. And one of the most common and most widely used thing in our industry is using X509 certificates to prove the identity, right? You have, say, you go into Google and you see this log sign in your address bar, and you click here and see that your website that you're hitting is actually website that you want to go. And if there's no man in the middle attack somewhere inside your data in your provider, no one will intercept the certificate and swap it with something. No one else will be able to look at the encrypted traffic. So we use this information in order to encrypt traffic between our application. How about we use this for our application? So if we can use this application, if we'll just step back to this example, now we need to include, now we need to include information with the certificate with this request. But here's interesting thing that happens. So when we travel to places, we need to have a passport, and passport will be issued us by government, that our certified authority, that everyone agrees that this is the place where the people are working in order to certify, uh, like for you, and the people would know that this is you. This is the passport that certifies that's your identity. Now we need to have a similar thing in the world of our services. In the world of SSL certificates, there is a certified authority that will be issuing this certificate, and you need to provide enough information to prove that this google.com is actually google.com, and it serves information that google.com serves, which is search. For many cases, you need to interact with certified authority, and the certified authority need to issue certificate. Plus, how we can extend this information in order to how we can use this information for our services. And it turns out that it's actually a lot of work to do this. So you need to have for each individual service, you need someone will issue you a certificate. Now with this certificate, your server needs to know that your client is also eligible for accessing the service. So we start talking about this kind of like a mutual agreement. And thankfully, over years, we already have established tools to do this. I'm talking about TLS, transport layer security, and the MTLS that allows the mutual notification between the services. So with this, you can go ahead and create some sort of like or like interact with a certification authority to issue your certificates. You need to provision your clients and server certificate. You need to make sure that the certificates are have a strong encryption strength, so no one will break this and replace them. Now you need to regularly rotate them. There's a lot of work. A lot of work needs to be done. It's possible. That's why one of the pillars, another of the pillars, apart from the identity of zero trust security, is automation. The process of providing this and rotate these things on the regular basis. And one of the tools that supports all these things, like at least two, I will talk a little bit more about other pillars of zero trust security in a second, but I want to introduce you the concept of the service mesh. Service mesh is the part of infrastructure where you deploy your applications. You can say, but Victor, it's all good, but like, what about developers? Can we develop this stuff ourselves? Yes, of course. There's a plenty of different frameworks available for different languages that allow you to do the thing that I just described, to support this MTLS and TLS and allow you to automate all this certification. But I know Java very well. My friends know Go very well. Other team members know .NET very well. But some of the frameworks might have their discrepancies. How we can make sure when we're running this inside the organization, how our IT department will make sure that our applications follow the same standard. So it's easy. You can say, hey, everyone is writing in Java and using Java, and that's it. So that would be one of the approaches how we can solve this problem, standardize on the language and the framework. So in this case, you don't have other options for other developers. However, with microservices world, you want to hire more people to build actual functionality, not the writing infrastructure. So the service mesh allows you to create this infrastructure that will provide you with the layer of communication that will be automatically provision you with some of the components of the zero trust, specifically like MTLS, enabling MTLS. Also, another pillar of zero trust security would be observability. So constantly looking what is going on in your application and providing the also always understanding what is going on and how the traffic goes on. And another the pillar of zero trust security would be you don't trust anyone by default, meaning that you cannot enable communication one service to another. In general, if you publish microservice somewhere, you can say, hey, you can hit this microservice by this URL, and off you go. But like how you make sure if people are eligible to do this. That's another thing that the service mesh will take care of it. So discovery plus traffic permissions, and we'll talk about this in a second. So service mesh allows to have the consistent infrastructure for your application deployment that focus on these low-level things, including like zero trust components, including the traffic permissions, including observability, etc. Service mesh like Kuma not limit you on particular deployment model. Everything in the service mesh world, goes around the concept of sidecar. So essentially, your application will be there will be small component deployed next to your application that will perform some of the network communication. And the sidecar component or sidecar deployment is one of the things that Kubernetes deployments use very often. However, Kuma not limits you to deploy your mesh in Kubernetes. It allows you to deploy to anywhere else in containers, in the VMs, and just the bare metal. And it provides a unified way how your application can communicate. Plus, these days, different companies, they have strategy around multi-cloud. They have a strategy around multi-DC in order to prevent failures of one data center and have a disaster recovery strategy. So the Kuma supports this as well. You can deploy multiple meshes that will be controlled with one single control plane. And here's the question: what's the control plane? So let's take a look quickly on architecture of the service mesh and how it works. So brains of this operation, the things where you have basically applying all the policies, it's actually stored somewhere here. That's called control plane. Control plane is something that operator or system administrator talks to. And control plane might store information about different components inside the database, where is also it has a communication with the smaller components, those smaller components called data planes. And data planes components are deployed next to your application, so they will be transfer all the traffic control or handling on the traffic control, handling situation when you need to provision new certificate or rotate certificate, handling the traffic permission and seeing if the request from particular service came in and you actually can access to the service. So those data planes can also perform in situation where they can lose connection to control plane because the configuration is persisted, and if control plane will go down, data planes will continue to work and operate with the previous version of configuration. Now, the one of the things that I also mentioned that you might want to deploy your application or like your application in multiple data centers. So in this case, you can can leverage functionality that allows you to deploy across multiple different zones. It can deploy even different clouds, but one control plane will control everything. So the way how it looks like here with the Kuma, there's a global control plane that controls all the things, and each individual zone will have their own control planes deployed. He say it's going to be AWS, it's going to be GCP, it's going to be Azure, something like that. And the global control plane would be deployed, I don't know, like my data center, my DC. And all things will be controlled over there. And the different version of application can use location-based gateway approach. So they don't need to hit the services where you need to pay for the extra traffic when they will travel across different networks. So that's one of the things. So next thing is that about usability. So the Kuma provides you with the API that you can hit through HTTP, or there's a UI that allows you to access with this and see what is going on with the mesh. The way how you configure, you're applying different policies, and we will talk about these policies in a second. But like before we jump to these policies, I would like to talk about the things that out of the box available, so you don't need to do anything. So essentially, the security policies and specifically MTLS can be enabled in the I don't like to say in one click because you don't click in actually. You either using command line tools or you're using API call, but you can apply this by just calling one API call, and the mutual TLS will be available. The way how it would be done, you issuing the particular configuration to control plane. Control plane will send the command to the data planes, and data planes internally will, will communicate with certificate authority in order to acquire this certificate. And after they apply, and they switch communication to secured TLS connection between nodes. This is first thing. You have a secured communication. Second thing, you have identity. Each service will have identity. How the service will have identity, X509 has this concept of SAN, a service alternative name, and the service alternative name inside the certificate can be used to identify particular service. So we know that when we have this communication between two services, that this particular service calling another service, we will have identity. Next thing, when we need to talk about some of the traffic controls and providing the traffic level permissions, that you don't need to, each individual service don't need to communicate with each other service. We can be very explicit about who can access what. So in this case, we will have traffic routes in order to control how the messages will flow. And we have circuit breakers deployed in case of failures of the certain services. So our service will not fail and in a kind of like in a cascade fashion. Same thing with the rate limiting. If someone is trying to access us and we're not able to perform this fairly quickly, we can implement this rate limiting strategy that will pushing back some of our requests from the thing. And another thing is the observability. So the constant monitoring, constant metrics, and seeing how the traffic, how it flows. Traces are important in distributed systems, so you would know who calls what and how things work. Let's take a look on this the policies that I was talking about. So here's the example of Kubernetes native custom resource definition that defines a policy for the MTLS. So I'm specifying that I'm going to be using built-in backend for certified authority. So in this case, I'm saying this one. And after that, I'm providing the parameters for my certificates. I'm using 2040K encryption and expiration 1 day. And the service mesh will rotate those certificates once in a day automatically for you. So next example would be use so-called traffic permissions that allows you to have a fine-grained control over which service can go to which destination. In this particular case, that's the default policy, allow all traffic. But you can revoke this policy, and after that the traffic will be disabled between the services, and after that you can gradually enable all these things. A little bit advanced feature that available as a part of enterprise implementation of the service mesh. We call it Kong mesh. It's called OPA policy, open policy agent, that allows us to have a fine-grained control over not only traffic, but specifically methods. So for example, we introspecting if the one service is calling another through HTTP request, and we will blocking this, by default, we disable access if there would be no secret that would be part of JOT token. So that's just example, but there's more. You can disable particular requests, different request types. For example, you can disable all post requests, making the service read only gets will be available, and so far and so on. So let me sum this up a little quick for you. So when you're thinking about security in the microservices world, think about this, achieving the zero trust by design. So don't trust anyone, disable be explicit about communication, and enable encryption by default. It's not difficult. Automation is your friend, and you can automate all the things by implementing this type of stuff. So fine-grained traffic policies will help you to establish a better understanding how your services communicate, and It will help you to decrease the vector of or like a rather field of attack. So you would know that there's a specific routes all the services can communicate. Please don't use like hello communication from one service to another. Plus, with this centralized control plane, you can enable a centralized access to all these things through different policies that you can enable. And some of the things that are available to you out of the box if you're using Kuma open source service mesh, MTLS will be working out of the box. You can use built-in certified authority. Traffic permissions also part of Kuma open source mesh. We added some of the advanced features in Kong Mesh Enterprise Edition. We're integrating with HashiCorp Vault to make it as your certification authority, and the data planes and control planes can communicate with it. And enable these open policy agent policies that provide fine-grained control over not generic traffic, but rather particular features and particular methods. Plus multi-zone notification that available across different deployments of the zones. And one of the things that we're working right now, like as I speak, probably already will be released, is the role-based access control that also will be part of Kong Mesh. So with this, if you probably want to learn a little bit more about how does it work, I prepared some demo that you can go ahead and check this out right after this presentation. You can find this link here. It breaks down the idea that, you have an application, you have your database, and you deploy some of the tools together with your database, how you can disable those tools accessing this production-based database. So go check this out, this demo, and subscribe to Kong Inc. YouTube channel for more content around cloud connectivity, security, and the service mesh and gateways, and join our community. And with this, my name is Viktor Gamov. As always, have a nice day.